Good morning, Algebra 2. Here we are in section 6.4 doing one of my favorite things, completing the square. So today we're going to talk about this very powerful technique of solving quadratic equations. And this is powerful because you can solve any quadratic equation this way, even if you don't like this method, right? So even if you can't factor it though, even if you can't factor the quadratic equation like we were doing in the last section in section 6.3, here you can solve it by this form. So the concept that we're working on is the fact that if you have x squared equals to n, then what automatically flows out is that x is either equal to, taking the square root of both sides, x is either equal to plus or minus the square root of n. And so that's what you see up here. And this is a concept that you should be familiar with. Let's take it and apply it to this other idea. Now I'm going to just put this little interim idea. So here's the idea. If you were to take, like, let's say x plus 2 quantity squared, I'm going to just take several things and square them, okay? Several binomial expressions and square them. Let's do x minus 5 quantity squared. How about an x plus 1 here? And if I were to square it and FOIL it out, FOIL each of them out, I would get this. I would get this situation here. I would get these trinomials, all right? So three terms, trinomials. And what I want you to see is this is a desired result, a desired situation that we want. We want to get perfect square trinomial situations. And to engineer that, because that's literally what we're going to be doing, I want you to pay attention to the B term and the C term of each of the trinomials that we got from foiling. Okay, so just take a look at these for a second. And what you'll notice is that if you take the B term, divide it by 2, and square it, you get the C term. Take the B term, divide this by 2, negative 3, square it, 9. Take the B term, negative 10, divided by 2, negative 5, square it, you get 25. Take the B term, divide it by 2, square it, you get this. Now this is a specific case, I'll be honest. Right now we're talking about a situation where the coefficient, the A value is 1. So we would have to do something, we would have to make the A value 1 in order to do what I'm trying to do next. But just hold on to the fact that anytime we have a perfect square trinomial situation like this, where that lead coefficient of the A value is 1, and you can see this situation here where the B term squared, half of the B term, square it, you get the C term. When you have that, I want you to know that you have this. You have a perfect square trinomial. How does this have anything to do with what we're going to do? Well, you'll see. So we're going to deal with this equation with rational roots, and we're going to solve it by the square root property. So what you notice here, they set up our situation. We haven't actually had to do anything here. What we're doing is we're going to solve this quadratic equation without putting it in standard form. So to solve it using completing the square, we're not going to necessarily have to do this. What we do here is we want to make sure that one side is a perfect square trinomial, as we have here. Look, the B term cut in half squared would give me that 25. So I know that I can factor this, or I could just factor it because I know how to factor. I can factor this as x plus 5 times x plus 5, or x plus 5 squared is equal to 49. And this is beautiful because it allows me to take the square root of both sides, and I get x plus 5 is equal to plus or minus the square root of 49. So you see where we're playing at, right? We're thinking about this situation. When I have something squared equal to something else, if I take the square root of both sides, that x side is equal to plus or minus the other side, plus or minus that n. All right, so let's come back over here. So this thing squared equals 49 means that x plus 5, the square root of that, is equal to plus or minus the square root of 49. We know that the square root of 49 is 7. So I need my plus or minus 7 here, and then I have x plus 5 over here. I'm going to finish off solving this by subtracting 5 from both sides, and I get that x is now equal to negative 5 plus or minus 7. This gives me two different answers. Negative 5 plus 7 gives me a positive 2, and negative 5 minus 7 gives me a negative 12. My two solutions, it would be that x is equal to 2 or x is equal to negative 12. And this is, in essence, like a very nicely engineered completing the square problem. So let's see if we can find out how to do it when it's not so perfect. They gave us another one that's nicely engineered, but that's okay. We got plenty of examples. Let's go ahead. So this one, again, what we're going to do is we want one side to be a perfect square trinomial, as this is. Half of this b term, quantity squared, gives me 9, so I know that I can factor this as x minus, and you can factor x minus 3 quantity squared. You could just, factor it how you usually do, and then you get x minus 3, x minus 3. So you know it's a perfect square trinomial, x minus 3 quantity squared. Next, we're going to take the square root of both sides. So x minus 3 is equal to plus or minus the square root of 32. Following with what we did last time, we're going to get rid of this negative 3 by adding 3 to both sides. And when I add 3 to both sides, I'm isolating x, and I get 3 plus or minus the square root of 32. So what they're showing us here is sometimes here's a situation where this bad boy up here would have been factorable. That's why we got these nice answers, and we could have gotten this by moving everything over to one side and factoring it. So we're seeing that we can get rational roots with this thing that we're doing called completing the square. But we can also get irrational roots, which is something we would never get if we had to factor. There was no way for us to do that. And so this is showing us a little bit of the power of our completing the square method. So finishing off, the square root of 16, you remember how we simplified the square root of 32 rather. The way we simplify this is recognizing that there's a 16 in there. This is really 16 times 2. So the answer for me would be 3 plus or minus 16 square root of 16 is 4. I don't know why I can't say words today. And then I have the 2 left inside. And yeah, we would leave it like this. I mean, sometimes some people might ask you to write it separately, but since it's not coming out to a particular number and it's not necessarily simplified, I think leaving it like this is just fine. All right. Okay, so let's look at this one. So now we're going to really figure out what we need to do in the topic of completing the square. What value of c they're asking is going to make this a perfect square trinomial? Since this a term is just 1, I'm good to go with the thing that we talked about earlier. Divide this in 2 and square it. So x squared plus 12x plus this c value that I'm looking for some c value. What would that be? It's going to be the b term divided by 2 squared. And I've said it a few times already. So when I take 12 and divide it by 2, right, I'm going to get 6, and 6 squared is 36. And this now is a perfect square trinomial. And so if I write it out, if I factor this, it's going to be x plus 6 times x plus 6, or neatly written as x plus 6 quantity squared. How do I know how to factor it so quickly? The value is going to be x plus or minus, depending on this first sign here, and it's going to be whatever b over 2 is. So b over 2 is 6, and so that lets me know how to factor it. So I don't know if I was doing that too fast before, but over here, when I knew that this was going to be a negative 3, negative 6 over 2, negative 3, that lets me know that I can factor it quickly. Does that make sense? Hopefully that did. All right, let's go ahead. So this is all we need to do. Yay, let's do example 4. Example 4, we have solving this equation by completing the square. They do not want me to solve it by factoring, so we know that this is not the form we're going to use, but let's go ahead and get started. X squared plus 8x minus 20 is equal to 0. First thing we want to do when completing the square is get rid of the constant term. And when I do that, I'm going to add 20 to both sides, and I get x squared plus 8x is equal to 20. Notice this big old gaping space that I use. What I'm going to do is show you how I'm going to add a specific thing. But you know in math, you know how we roll. To keep the equation equal, to keep it balanced, what we do to one side, we do to the other. And so I'm going to do exactly what I know to do. I'm going to take this term, divide it in half. You remember, divide the b term in half and square it. So b term in half is going to be 4, square it, 16. What I do to one side, I do to the other, right? Keep it balanced. And now what I have on this left side is a perfect square trinomial. I can factor this bad boy. And so I get x plus 4, right? The b term cut in half, quantity squared. And you can FOIL it out if you're feeling like we're doing funny stuff. It works. And then on the right side, I have 36. So the question is, how do I solve it? Well, you know, we're doing the same thing. We're going to take the square root of both sides. So on the left side, I have x plus 4 is equal to plus or minus the square root of 36. And then so x is equal to, subtracting 4 on both sides, I get negative 4 plus or minus the square root of 36. Does that make sense, guys? I hope so. So now I'm going to finish it off. Negative 4 plus or minus the square root of 36. Square root of 36 is 6. And look at this. I'm getting two normal answers, no radicals. These are really, the better way to say this is rational answers. I'm getting two rational answers, which lets me know I could have factored this. And you probably saw that earlier that it was factorable. But let's go ahead and do the thing. So negative 4 plus a positive 6 is going to be a positive 2. And then negative 4 minus 6 is going to be a negative 10. And those are my two answers for this problem. X is either equal to 2 or x is equal to negative 10. Okay, so we're talking about equations where a is not 1. And so this is a little bit more tricky, but not really. It just makes it cumbersome. We're going to do exactly the same thing. Watch this. First of all, I'm going to make a 1. You heard me. I'm going to do what I want to do. I'm going to divide everything by the a term. So the a term is 2. Let me divide both sides by 2. And so now I get the one that works really well for me. So x squared minus 5 over 2. You see the problem, right? I now get fractions. Fractions. It's okay. We are strong. Is equal to 0, right? 0 divided by 2 is 0. So this is the same exact equation, totally fine, but now I can apply the thing that I knew how to do before, which was take the b term, cut it in. Okay, let's get there. So we're going to do what we did last time to complete the square. But watch this. First thing I do is get rid of the c term. So I have x squared minus 5 over 2x is equal to a negative 3 over 2. Notice the space that I'm leaving on both sides. Now I need to add the b term cut in half and squared. So if I divide something in half, basically I'm multiplying by 1/2. So 5 over 2 times 1/2 would be 5 over 4. But remember, I take the b term, cut it in half, and square it. So this is going to give me a perfect square trinomial. Crazy, right? But pretty cool. We just do the same process. And so what does this look like when I factor it? Well, x minus this term cut in half, 5 over 4, quantity squared. And if you feel like multiplying to confirm it, please do. Enjoy. I'm going to try to do a little bit of simplification here for my purposes. And so I realize that I get negative 3 over 2 plus 25 over 16. I'm going to use 16 as my common denominator here. So I end up with 16, 8. 8 times negative 3 is going to be a negative 24. Right? So then I have that. Still on the left side, I have x minus 5/4, that is, sorry about that, babies, 5/4 quantity squared. And then I simplify this to get 1 over 16. And it's not such a bear after all. It's not too bad. So now what I'm going to do is take the square root of both sides. So I get x minus 5 over 4 is equal to plus or minus the square root of 1 over 16. Let's keep it going. X is therefore, adding 5/4 to both sides, x is therefore equal to 5 over 4 plus or minus the square root of 1 over 16 is really 1 over 4. Oh my gosh, this is lovely. X is equal to, so I got two different answers. 5 plus 1 over 4 and 5 minus 1 over 4. 5 plus 1 over 4 gives me 6/4. And 5 minus 1 over 4 gives me 4/4. I should put an or here. 4/4. And we know we can write that as that x is equal to 3/2 or x is equal to 1. These are rational answers, and we would have been able to factor this. But this was pretty cool. I'm going to see you guys in another video to finish up our lesson. Make sure this makes sense. Let me know if you have any questions, and I'll talk to you in a minute. Bye-bye.